next homework. And I put a lot of time and thought into the homework. That's why I don't want to rush and just send something out. And same with your grading. I can't sit there and just pretend like check off things. I'm going through everything and giving you feedback. So what you probably are going to get is just a little bit updated from your 6-week grades. I'm going to put the midterm and everything in over the weekend, but your 10-week grades are due on Friday today. So there's no way I'm going to crunch through that and just get it done. It's just not fair to you. But if you did everything right, you shouldn't be having bad grades anyways. All right, so I think some of this Dr. Sarajin gave you already, but I'm going to start from here, and I'm giving you a choice of a coding assignment for next time. With the coding assignments that I give, I have no issue with you using generative AI. I use it too. I mean, it's been, you know, when I first started coding, it's back with Fortran 77, and we didn't have anything like the faculty member would just do lectures and then give you assignments, and then you go home and your code doesn't run and you get points off. You know, it was very different. But once the internet started and you had ways to just go and check code, I've done that all, you know, for most of my coding life is just pick up stuff from Google. So if you want to like put stuff, I just want to know how you did it, where you got it from, and no packages other than pandas. So, you know, if you find a package that does a Euclidean algorithm for you, that's not going to, I want to actually see you put those pieces in and comment out your code. You should like that. I don't know if you can get R to do something like that. Seems like an abomination. Seems like a Python exercise. But just to start out, the division algorithm. He probably gave you this, right? Maybe. So given A, B belonging to the natural numbers, and B is not 0, there exists, so this is there exists, unique integers, so that's really important that they're unique, Q and R, with R between 0 but strictly less than B, such that A is equal to BQ plus R. So in-class assignment, you get to say it was a Thayer upon Thayer week, right? So I'm gonna get you up to boards quickly.
And could you go over the way you say the definitions of given A and Z belong to natural numbers?
B with B not should be a comma there. B not equal to 0. There exists unique, so B can't be 0. So you have to choose. So in my list here for you guys, I have nothing that's 0. There exist unique integers Q and R with R between 0, it's allowed to be equal to 0, and strictly less than B, such that A is equal to BQ plus R. When my number theory teacher gave me this, I thought it's just long division. And then I started using it in proofs. Like it's a really important theorem. So run through a few of these at the boards, like warm-ups. All right, go for it.
That usually 2 dots.
No, it's a backward. 2 dots, yeah. Such that inside the set notation, yeah.
That's different. Oh, just different.
Yeah, it's in set notation. So let me put that in here. So such that.
So that versus that's like that notation.
I don't know. It's you'll see it again if you take another class in this area.
Okay.
like in pure math. Maybe not even, you might see it in 476, if we take that.
I already took 476. They might have done it, but I think you usually use just S dot.
Yeah, complex.
Yeah.
For five.
Yeah, I was just wondering.
Oh, this is Q.
Yeah.
Sorry, it's mine.
They're gonna be impaired.
Yeah.
Yeah, I'm saying.
There are a lot of different answers. No, unique. Oh, so they're unique and.
That's good. Yes, ours is legit. Yeah.
Oh, I see.
Ours just. Yeah. That was this cute. It is. It's supposed to say it's lots of everything. It's fancy. It's not like it's not that. I see it's nice. It's great.
It should be fairly straightforward and easy.
Wait. Isn't it the same number?
No, it's just that R has to be less than B, so. If you use anything other than that. Then the R.
That'd be less than
8.4.
Are you?
Yeah. See less than, yeah.
Oh, less than 2.
Also, B can't provide it. Or well, I guess B can. It's not gonna be like that.
You just can, yeah, you can.
They're both right.
All right. Is this theorem still true? If I drop the fact that R has to be between 0 and B. Find me a counterexample or prove it if you think it's true. So I forced R to be between 0 and B. Is the theorem still true? I used to hate my professor. When he said,
No,
like,
no, it's not. You can have multiple.
Anytime. They're the one.
For this first one? So
Yeah, they can be the same. Yeah. Weird, right? But they can be the same. But they're unique, right? Q and R are unique because I forced B to be between 0 and R. But what if I lift that restriction? See if you can find a counterexample where the theorem's not true.
Yeah, so R is very. It's very unique.
And what did you say the second part was? You said.
What if I lift this condition? So I don't any longer have this restriction. R can be anything bigger.
So wait, B can't be 0? Or-
You can't be 0,
Okay, yeah.
but I'm gonna allow this to
Sorry.
lift it. Can you go back to your previous examples and come up with other ways to generate Q and R? To show this is not true, you just need one other example because then it ruins the uniqueness.
that work? Because if R A is equal to R, then you would have to be zero.
You can't say A and B are given to you to start with, just like I could do A and B here. Can you find a combination of Q and R that's not the first Q and R that you just came up with? Relieve that restriction, that zero, that R has to be strictly recipe.
Oh, that it still works.
Yeah, it still works, but the A and B can't be chosen, they're given to you. So.
It's been only given so time, yes.
Okay, so are you going to
But
A?
that, yeah, I know what you're asking. It was not.
It was too good calculus, but it was like.
Yes.
Read it
Don't worry,
well.
you can
No,
set already.
it's like.
We run the numbers.
It's exactly, you drop like. Damn, I don't know what this guy did. God, it was that R.
Yes, R does not have to be less than B. Anybody everybody find a counterexample? That restriction 0 to between 0 R, B, that restriction makes that uniqueness happen. So I'll let everybody catch up, see if you can find your own example.
Hey, step side. Yeah. But you pay out of the accuracy. Yeah. I guess you can't make it like too arbitrarily high because something that company is too expensive, but like, be ready in case you can't. It's like.
Once you found a counterexample, sit down so that I know who's done.
It's basically. Well,
Yeah.
like, do you put it-
We're getting there.
Got it.
Right, even when it's, even like. It's very technically telecom.
Like, I was like, right, I get the message. Like, do it, it's still there.
Turtle to the street.
That's the number three. You may grow it. Here's something.
I don't know, but it's like, it gets me going every time. Yeah, I love it.
So I hope that even if you've taken discrete math or abstract algebra or one of these other classes, that you're getting something out of this class, especially because I'm not going through a book. I'm actually just picking topics. Thinking knot theory is next. This is an area I really like, and you probably would have never seen before, and I think it's really cool. My favorite area though is this stuff here. Just because there's so many open problems that you can ask that seems so simple. So in those open problems that Dr. Sarajan gave you, you don't have to solve the problem when you just take one of them. You can actually throw some data science at it and simulate the heck out of it and see what happens, or look at patterns that you might see. So Dom Rudakevich actually last year took a problem that was open and just showed some patterns in it that were new, because typically somebody who's working in this area may not actually do a lot of computing. So that's what you could bring to the table, just to fool around with it. And the reason I want your final to be that is because when we were younger, little, before we actually went to school, we were curious about things. And we were never when you go to school, you can't be curious about things. In fact, I used to get stuff marked wrong if I did it different than the teacher asked me to. You know, that's actually a horrible thing to happen, because it kind of squashes your own creativity and innovation when you've come to solve a problem. But I remember one time somebody asked me what the sum was, and it had like an X in it. And I went to Mathematica and I ran a loop, had it actually calculate. It was when Mathematica first came out. And I came back to him and I said, the answer is this. And he goes, well, where's the proof? And I said, you didn't ask me for a proof. You asked me what this sum equals. Mm-hmm. And he said, that's not acceptable. Like, I thought it was pretty creative. Mathematica just came out and I went and ran a loop and had it do that sum and figure out what it was and came back. And so the amazing thing is that professor is actually using computing now to do phylogenetic trees. But if you ever go into teaching, which some of you might actually, my daughter's math teacher in middle school was a West Point graduate. And so just remember, don't squish somebody's creativity out of the way. Like you want to that stuff up. So that's why I want to give you open problems. Just play around with it. Be little again and just enjoy fooling around with a problem and giving you lots of choices to pick from so that you can pick something that's interesting to you. Euclidean algorithm. So these problems actually get more and more difficult when numbers get large, and you'll find that people will, there's a math news where someone will find something with a computer. So you want to be able to compute some of these things. And our government issued laptops might be one place. Suppose I want to find the Q and the R. So I'm given the A and the B. So I start here. You kind of have to go backwards. I'm kind of doing this to show you where everything's going. Sorry. So this is not different than if you took MA 103, this is a recursion formula that you give it an initial seed and then you iterate forward in the iterate. Well, I shouldn't have actually called the first ones. Maybe I should have called this 0, Q0, R0, like that. So like that. So you're iterating forward in time. And then what's going to happen? I'll wait till you catch up writing this down. So the Euclidean algorithm is a way to find the greatest common divisor, because when the numbers get large enough, finding the greatest common divisor is really difficult. Did Dr. Sarrazin talk about Mersenne primes? Okay, we'll do some cool stuff with that too. Get this algorithm down. So in your next homework, I give you the option of programming this where the user inputs the A and the B. Your code runs the algorithm and spits out the final thing for them. So it's looping. It's not that hard. You might have to be creative how you get that input in and how you spit the output out. Yes, this is a plus. Sometimes my pen doesn't give me the. No, wait, R1. Let me just make sure my things are correct. Yes, this should be +1. This should be +2, correct. I have a problem with indices.
Are the B equals to the R and I equals, are those both Q1? Or does it increase?
See, Q2. Let me see. Because I changed my mind, you know, I put R0 here. So this should be R0, Q1. And this is Q0 up here. No, it's correct. And then, yeah, it's correct.
So it stays Q1 for both, like.
It's not a Q1, right? Let's see. Yeah, you're right. Q2. They jump up. It's an important question because I'm gonna have you run something, okay? All right, so let me finish this, the Euclidean algorithm is actually a theorem. Then for k large enough, say k equals some t, then you're gonna get RT minus 1 is equal to RT times QT plus 1, no remainders. And this will be the greatest common divisor. So if you're coding, you want your loop to do a while, just have it stop. There's different ways you could do this. This is just a way to find the greatest common divisor. It's actually so simple, you can program it in Excel. And you're welcome to try it. I'm going to give you a couple problems to try out. You can certainly use your computer and try it out on the computer. Code it into Excel would be really fast. You just have it read the previous cell in. All right, let me give you a couple to do. As I caught up? Okay. Try. Find these two. 280. I just made them up. Using the Euclidean algorithm. Natural numbers. All right, yep. You can do it on the board if you want. Might be hard, but or do it on paper first and take it to the board when you finish. So you have